from Einstein Bagels. Yeah, this weekend just didn't quite.
Where'd you get that?
Yeah, if I got it at Best Buy, it'd be like $87. Right? And they say, it's too. Yeah, exactly. All right. Boop. All right, guys. So here's the plan for today. I want to do a little review, and then I've got some problems for you guys to work on. It's kind of a review of everything we've done in chapter 4 so far. And then we're going to try to finish out chapter 4. We'll see if that happens. And got the quiz. Yeah. Thursday. It's going to be. Ooh, yeah. It's basically going to be 4:1 through 4:5. Oh my gosh. So adding, subtracting, like denominators, unlike denominators, multiplying, dividing fractions, mixed number stuff. You look appropriately not excited, I understand. Just be ready. So before I get into like a review, you guys have any questions from homework stuff? I almost had a question. No, that's the point. I want to get you started because then it makes the class work better. You guys doing all right? You had a good weekend?
No.
I'm sorry. Huh? I understand.
We have lots of questions.
Okay.
You answer history questions too?
Sure. They won't be the right answers, but I can answer them. Four two. What? You guys.
Yes.
4:1 through 4:5. Yes.
4:5
Yes. 4:5 in.
This Thursday.
This Thursday. That's right. Not just any Thursday. Every Thursday, Randall. Yes.
Are we doing 4-6 and 4-7?
Totally are. We just haven't yet. So I don't want to put that in the quiz. That would be really mean. We will. We're doing it today. Yeah.
So let's do 4.2, page 313, number 165.
You don't just go 1 to
65. I did it already, but I just want to make sure I'm right.
Oh yeah. That one looks gross.
It's nasty.
All right, guys. This is I already forgot what I just said.
165.
4.2, 165.
Huh?
Did you try and go? Yeah, I know. Which one was it? Was it 174?
78 to 174.
Was it 174?
Yes, we did. Every 3 other 178 to 174.
Oh my God, there's so much happening.
It's funny too because I messed up yesterday. And I totally
It's funny.
I messed up. I looked back.
It's just a dream. No, it's not. It's not.
I did that.
Okay, let's see. You guys ready? It doesn't matter if you are, because I'm going to do this now too. So. All right. Now, if you wanted to, if it makes it easier, you could always put any whole number in a fraction problem. You can make it look like a fraction by doing what?
Putting it
Yeah, every single whole number, you can put a 1 underneath it. It doesn't change the number. So I don't know if that helps, or if it helps, then you can automatically, now it looks like you have like a true, everything's fraction. So that might, for some people, that helps. Now remind me, how do I divide? I showed you some freaky ass stuff as to why it works the way it does. But of course, how do I do it?
Flip it.
Yeah, flip what?
The 503.
Yeah, the second dude. So you multiply, make division
Multiplication.
Can become multiplication all day long as you flip the second dude. Alright. So notice a couple things. This is the way I always do this. What happens to the negatives in this problem?
They're going to cancel out.
Good, there's two of them, so they're going to kill each other, right? Any pair of negatives in a multiplication and division problem are going to kill each other. So I can kind of take care of that. Bam, bam. So I don't have to worry about that anymore. Now, what's the other thing we look for when we're multiplying fractions before we just start multiplying? Yeah, I like it. All right, ready? Ready? All right, here we go. Here we go. Oh, here we go. Real quick, I like what somebody just said. You do not need LCD when you're multiplying or dividing. We never do, ever. What's x plus, let me see if you guys are cool with this. What's x plus x squared? Can you combine those? Or are those like terms? Those are so desperately not like terms. I have an x, and I have an x squared. Now, if I had x squared plus x squared, what's that?
X4.
What do you see how many of? What do you see how many of? I see two whats? What do I see? I see two whats? No, I see two whats?
2x.
X's.
No, I don't see any x's. I see two x squares. That's what the answer is, because that's what I see. Now, if you put some kind of x to the fourth down, I'll be like, how the hell did you do that shit? That's miraculous shit, right? You're just making it show. Oh. So if I have x cubed plus x cubed, the answer is not x to the sixth. I don't see any freaking x to the sixth. But I see two x cubes.
2x is 3.
So remember, exponents are based on what? What are exponents based on? What operation are exponents based on? Multiplication. So they will only change when you multiply or divide. That's the only time they can change, because that's what they are based on. Please let that make sense. So I'm just consolidating what I see here. I see two of these. That's what coefficients are meant for. They change with addition, subtraction. They just consolidate what you see. Now, let me ask this. So then what's x squared plus x cubed? Are those like terms?
No.
Hell no. So can I add those? Hell no. So I need like terms when I add or subtract. So I need like denominators when I add or subtract. Because like denominators is like terms. Please go with me. Now watch this. What's x squared times x cubed? Anybody know? How many x's do I have? I have two x's times three more x's. No. Two x's times three more x's is how many x's? 5. So when I multiply or divide, it's not as restrictive. I don't need perfectly like terms. I'm trying to desperately show you. Fractions, when you multiply or divide, you do not need like denominators. You don't. Because the whole point of multiplying and dividing is to try to reduce when you can. Why would you build things up? So here, what I really want to do is reduce what I can. Not build anything up. What goes into what?
5 goes into 3.
Yeah, 5 is on the bottom.
Divide by 5, 1. Divide by 5, 3.
So anything on the top, anything on the bottom will cancel. And exactly why do those cancel? Because the bar means divide, and the dot means multiply. So I have opposite operations. Therefore, cancellation makes sense. Right? And just to finish this out, now what do I get? 3 times 3?
9. Over
1 times 1?
1.
And of course, that's just
9.
9. Okay. Now, let me follow it up real quick.
Where'd you get the 9?
3 times 3? Yeah.
There's like an addition.
That's a positive 3.
Oh.
So it doesn't even have to be written. I want you guys to really, really realize, when I write -7, I have to write the negative symbol, because we know that if there is no symbol, it is assumed to be positive. It could have been that we put -7 and we put +7. That could have been they could have said, no, you got to write the plus sign just to make it really clear. But no, they said, no. If there's no sign, we know it's positive. I like it. So why is that plus there? Because it was negative, but the two negatives canceled. So I just made them positive. Is that cool? I don't need the plus sign there. The only reason it's there is because I killed that negative sign. The two negatives cancel each other out. Okay. So follow up. Here's a mistake I see a lot. This year, right? I'm going to do something. I want you to tell me.
It's 4 or 9?
It's a 4. Don't tell me what to do. I'm going to show you something wrong. That's the whole point of this. I'm going to do something wrong. Don't write this down. I'm going to do something wrong. Don't write it down. Because later you'll be like, oh, is that how you do that? No. And why is that wrong? Look at that.
Wrong.
That is so wrong. Well, what's wrong with that? It's a 3 on the top and there's a 9 on the bottom. What's the matter with that?
Because
This is freaking subtraction. Does subtraction cancel division?
no.
Hell no. Please just let that make sense. So why is this allowed? Because multiplication cancels division. That's why. That's why it makes sense I'm canceling stuff out. Doesn't make any damn sense here. Here, of course, I'd have to get
Put the
LCD.
LCD.
I can't do this kind of stuff. No good. No. All right.
Could you show an example how to do that?
Oh, sure. Let's do that one. Where am I at? What did I say? 7 ninths. Why is this one a relatively easy LCD problem? Can somebody explain to me that? That this is an easy LCD problem. Why? What will the LCD be?
36.
36. So why is this one so easy? Because 9 and 4 don't share anything. So when you have two numbers that don't share, do you see what I mean? Like if that was 9 and 15, they share something. 9 and 15 share a 3. Then the LCD is not just 9 times 15. It's something smaller than that. But here, 9 and 4 don't share a damn thing. So what is 9 missing the 4? What is 4 missing the 9? Oh, they're missing each other. Yeah. So then what would you multiply him by?
9 times
4.
4. And what would you multiply him by?
9.
9. So then you would get
28.
28 over
36.
36.
27.
27.
1 over 3.
1 over 30.
Get back. So you desperately need like denominators because really they're just like terms. But you need it only when you subtract and add. Because that's the only time you need like terms. When you multiply divide, it's a little more free in terms of what you need. You don't need like denominators then. Maybe. Yes?
So the division is that the same column as the one under it?
Yes, this is how we do
So
division.
When it's division, you switch it to multiplication,
Yes, and I showed you the freaky ass reason why last time.
and then when it's multiplication, you switch it to division, or
Well, that would not make any sense. So we know how to multiply two fractions. Dividing fractions was a weird thing, but if I can rewrite it in terms of multiplication, I know exactly what to do. Technically, you could rewrite a multiplication to division, but then you're like, what the hell do I do? See, so that's why we make all the division problems multiplication, because then we know exactly what to do. We know how to multiply fractions.
and when it's like multiplication, you just do like how you do the multiplication, right?
Yeah, I look to see, is there anything I can cancel first?
You would just do it that way, and you wouldn't have to like flip it over. And then
If it started off as multiplication, I would just start doing this, by the way.
The division, you have to like flip it over, right?
To make it become multiplication, yes. I like it. Yes.
On that example, 7 over 9, that one. So if 9 and 4 doesn't go in, well, they do go into anything, but there's no like terms, right?
Yeah,
How would
so
you know what to write, like to times it by, to make the least common denominator?
well, when there's nothing common, you multiply each by the other one.
Oh,
So they need each other.
Because this has got a 9 on the bottom. This ain't got no 9, so give it a 9. This ain't got no 4, so give it a 4. Don't learn grammar from me, by the way. Hopefully you picked up on that. Here's the alternate idea. What you got, Jeff? I don't know. Right. And I showed you one of the best ways to do this because it's applicable later when the fractions get the variables in the bottom. Oh shit. This method works then too. What do they have in common?
5.
Yes, I'm not going to multiply this by 35. I'm not going to multiply this by 15. That would be horrendous. But you're multiplying by more than you need to because they already share 5. This is 5 times 3, and this is 5 times 7. So now you can see exactly which stuff each one is missing, right? This guy is missing a... No, he's got a 3. This guy is missing a 7. This guy's missing a 3. So then you give it. So what are you going to multiply this first one by? He's got a 3. 7. Do you guys see what I'm saying? He's already got a 3. Why would you give him another 3? He doesn't need it.
No.
He's got a 5 and a 3, but this guy's got a 7. That ain't fair. Can you imagine the little kids like, oh, you got a 7. You know, I always imagine these are little kids. They're like, all right, here's a 7. Be quiet. Oh, he's got a 3. Okay, here's a 3. Shit. Okay, now do they both have the same thing? Are these both the same?
Yeah.
753 is 573. They're both the same now. That's the whole purpose of LCD is to make them both the same number. So this process of breaking it down by what's already the same, and then whatever else there is, and I can see what to give each of them. Please let that be nice. Because now what's on the bottom for both? What's 7 times 5 times 3? 7 times 3 is 21.
75.
21 times 5 is
105.
105. Yeah. So this will be 49 over 105. This will be
14.
6.
Oh.
And 105.
over 105. Because he needed a 3, he needed a 7.
I thought it was a 7.
Oh, okay, I understand. My 3s are horrible. And then this will be, oh, thank you. This will be
9.
34 minus
43.
43.
Can you reduce that? You can't reduce that.
Yeah, 43 looks pretty prime. Right?
And then when it says, like, so you know how you showed me improper? Is that an improper fraction or a mixed number?
So guys, is this an improper fraction?
No.
Why not?
Because it already worked out.
Guys, no. Why is this not improper? Because the top is smaller than the bottom. I like it. Guys, thank you.
Fraction that
Improper fraction would mean the top is bigger than the bottom, which means there's a whole piece in it.
you just simplify. Yeah.
Right? So like 3/4, is that bigger or less than 1? Less. 4/4, is that bigger or less than 1? Why is that a weird? It's equal to 1. So 5/4 must be on the other side of 1. It's bigger, it's got a 1 in it. So it is a mixed number. It's not written as a mixed number right now, but it is.
Oh, you just said.
What would 5/4 be as a mixed number?
1/4.
Which kind of makes sense. This is 3/4 plus 1/4 is 4/4, which is 1, plus 1/4 is 1 1/4. That kind of makes sense. So the top has to be bigger than the bottom for it to be written as a mixed number. I love it. Sleep. Yes.
So the one you did right there is like another way of doing that also?
This year?
Yeah, that's another way of doing it.
No, it's not really another way because what do 9 and 4 have in common?
36.
No. What do they have in... See, here. What do 15 and 35 have in common? 5. So I wrote them as 5 times something and 5 times something. What do 4 and 9 have in common? Nothing.
If you like broke it down, like the tree you did right there, would I give you the two answers?
Of course. So this will be 3 times 3. This will be 2 times 2. So what's he missing that he's got? 2 2s, otherwise known as 4. What is he missing that he's got? 2 3s, otherwise known as 9. But there's no reason to do this breaking down if they don't have anything in common in the first place. If they have something in common, then I'm like, let me break it down so I can see. They already both have a 5, so let me not screw with the 5. It's just the other part that makes them different. I really want you guys to see that. Try to allow math to make sense. It wants to. Okay. Now that's not the only way to do this problem, but I'm trying to kind of push this on you because it actually makes later problems a lot easier. It makes these problems a lot easier. And it's good practice for breaking things down. A lot of good shit in there. I like it. Yes?
We do number 366 and 4.5.
Okay. 366. Ooh, I like it. Let me build up to that a little bit. Well, I guess I'm just going to do it. We basically, is everybody decent with these two problems? Please, dear God. Please, dear God. Don't be this person here. This is a mistake. Let me cross through right away. But right? That's a horrible mistake. What did this person do?
Just subtract
Just 7 minus 3 and 9 minus 4. And next one, Jeff, I'm ready. That was easy. What is people's problem? Please let it make sense. That doesn't make any damn sense. You can't do this. 7 of these minus 3 of those is 4. What the hell? What the hell? 5 dogs minus 2 people is 3 dog people. Right? They have to be like to be able to consolidate them. You understand? You with it? A little bit? Sort of? Not with the dog people. Don't worry about it. That's the late night creature monster movie. Okay. So watch this. Is it 1/4? Yeah. Oh, plus. This is 366. Please don't allow a variable to mess your entire day up when it shows up. Why do I not give a shit about that x at first? Because my whole thought process is based on what at first?
Denominator.
Denominator. And there's no variable in the denominator. So who cares about that x in it? I don't care about it yet. So don't just leave this blank if it's on a test or a quiz or something, just because there's an x in it. What's the LCD going to be? This is a nice one.
12.
Yeah, why is this a nice one? Because 3 and 4 don't share anything, so they need each other. Oh. Yes? No. Like so what do I multiply the first guy by?
4.
Because he needs the other dude, so he needs 4. So what do I get here?
4x. 12. 3. 12. 4x.
4x plus 3 over 12.
12. Finish.
I like it. Because if you really want to get down to it, I skipped a step here, sort of. This is a step we don't even consider, but the step I skipped is, I can write this as 49 minus 6 over 105. Right? If you don't do that, I'm with you all day long, because I know what 49 minus 6 is. But are you guys cool with the fact I could write this? And why am I able to do one more step? Because these are like terms. They're both numbers. So here, can I go any further?
No.
I can't add 4x's to 3. They're not like terms. So don't make it 7x. Don't do weird stuff with it. Poor little dude. Yeah.
Can you go back to 4.2 and do 159?
Oh yeah, just a second. Did you have a question about this here?
No. How many minutes for the quiz?
Oh gosh. All right, so quizzes are pretty much always 25 minutes or so. Yes. Yeah, the quizzes are nuts and bolts, you know it or you don't situations. Okay. Is everybody decent with that there? Which one do you say again? I'm sorry. 1.4.2.
4.2, 159.
There's one. Whoa. Oh, okay. So this is another one. 159, right? This is another one not to give up on just because variables dared to enter. That's an S, by the way. My S's and my 5s, I know. Oh well. So we know what the first step is. What's the first step in a division fraction problem? Flip it. Flip what?
To 18S.
Yes, the second dude always. Times
35 over 18S.
Let me stop there for a second. Bless you.
Thank you.
Yeah, good. So what goes in at 25 and 35? So 25 divided by 5 is 5. 35 divided by 5 is 7. 12 and 18, what goes into both?
6.
6 and the 12 is
2.
2. 6 and the 18 is 3. The R and the S, does anything happen to them?
No.
No, there's no other R, there's no other S to kill those.
No cien. Porque o 100 cada tarde buscan
So 2R times 7,
14.
14R. 5 times 3S, 15S.
There we go.
See, so when variables are part of a multiplication problem, it's kind of nice. They just come for the ride. They just come for the ride. I don't need like terms here really because I'm multiplying, right? Okay, maybe.
Maybe.
Could be.
Possibly.
Okay. Anything else from homework here?
Yeah.
Yes.
I didn't understand on 4.3 where it says 199. Number 199. Like those problems, I didn't understand the number.
Oh yeah. Okay. All right. So you thought it was just me doing my weird shit when I explained division, but it turns out that it's a valid problem to have. It's actually what's called complex fractions. Oh shit, that sounds good. So this is the fractception, right? No Inception fans? Okay. You can do it, little dude. There you go. All right. Where'd it go? 199. Now, the immediate thing you can do with this problem. Remember the way I explained division of fractions was to first rewrite it like this and then do weird shit to this. So when it's given to you like this, you just immediately write it in a better way. Can somebody read this to me? This is 4/5 divided by. All right, so write that. 4/5 divided by 8/15. And the minute you do that, it's a normal problem, right? Yeah, it'll be 4/5 times
15.
Yeah, and then I'm going to let you guys do the rest. Don't say anything. So they look disgusting at first, right? Fractions inside of fractions, like those Russian nesting dolls, right? It's another fraction. It's another fraction. Oh, shit. You can immediately write it in a better form. You guys agree that that's a better form? No? I think you guys are all like, I ain't going to say better because it all sucks. Oh, come on. This is a better form than that. I don't care how you feel about fractions. That's a better form than that. And these are both the same thing. They mean the same thing. So of course I'm going to write it like this. Hell yeah. And then you just do what you always do with division of fractions. Yeah.
What if, like, on number 206, there's two variables? What if there was two variables in some fraction?
We had this one that had two variables.
So it's the same thing?
Same thing.
Okay.
No problem. No problem. I know when you see a variable in a problem, your immediate reaction is, oh shit, everything's different. But that is actually so wrong. Because a variable, what is a variable? What is this? What is R? What is S? What do they represent? A number. They represent an unknown number. I love it. So how are they going to act? They're going to act like a number. Because they are a freaking number. Maybe. Okay. Yeah, I know. I didn't finish that because it's your homework. I'm not going to do all your homework for you. Shit. Man, Jeff, you suck. Oh, okay. All right. Anything else from homework?
Word problem?
Huh? I didn't give you any word problems. Yes.
Yeah.
I gave you. No. Do you guys know what a word problem is? It's a problem where you have to come up with your own equation. You have problems that have words in it.
Okay, well.
And then you have to add the fractions or subtract the fractions. Those are completely different ideas. Word problems are difficult. I'll give you that. They are difficult. These have some words in it. But what is it really at the heart of it? Do you add the fractions? Do you multiply the fractions? I mean, that's the point of that problem, right? I like, real quick though.
Page 363, number 432. The last one.
Keep this somehow. Pages keep flying off of this thing. All right. 363, number who?
432.
There you go. You guys, here's a wordy problem. All right, let's see. Loranda is making covers for the throw pillows on her sofa. For each pillow cover, she needs 3/16 yard of print fabric. All right. So for each cover, she needs 3/16 of a yard of print fabric and 3/8 of a yard of solid fabric. How much total fabric does she need for each pillow cover? So what am I going to do with those two numbers?
Or do the
So real quick, in case your brain kind of says fractions, oh shit, make this 2 yards and 5 yards. Just make it whole numbers. So if she needs 2 yards of print and 5 yards of solid, how many total yards does she need? 7. Right? 2 yards and 5 yards is 7 yards. So what operation is that? Addition. So now take the grosser numbers and you do the same thing. Yeah, you just add them. And then you need LCD. Do you see what I mean? That's not really a word problem. It's just, here's numbers inside of a story. Do you know what to do with the numbers? That's really what that is. You guys okay with that? You guys see that? No? Are you guys? Yes? All right. You got a thumbs up in the back. I'm going to just go with that. The rest of your life, just... Can I go yet? Yes. Come on, guys. Does it make sense? I mean, yes. Okay. I'm done with that one. What you got?
174 on 12.
174.
Yeah. 313.
Say again? Sorry? Oh, yeah. 315.
313.
Well, 315. Oh, I see. That's hilarious. All right. So basically this says a medium pizza can be cut into 6 or 8 slices. And then he said, would you rather have 3 out of 6 slices or 4 out of 8 slices? Which one would you rather have? 3, cut it into 6 pieces and you take 3 of them, or you cut it into 8 pieces and you take 4 of them?
It would be this.
They're the same damn thing. What's 3 over 6 reduced to?
Half.
A half. And what's 4 out of 8 reduced to?
Half.
They both represent half the damn pizza. What I love is so many people in the world have trouble with math to the point that they don't realize they're the same thing, and then other people can take advantage of them for this fact. Right? So you could say 3 out of 6 slices would be $5. But you know, I'll give you 4 out of 8 slices for $5.50. It's only 50 cents more. You get a whole other slice. And oh yeah, sure. That kind of thing happens all the time. You don't even realize. But you're better than that now. You know that 3. If I cut a pizza into 6 pieces and take 3, and then that's half the pizza. Cut it in 8 pieces, take 4 of them. That's still the same exact half of a pizza. Exactly the same. Now, if you have small hands, like somebody, and you're like, I want a smaller piece of pizza that I put in my mouth, then you're going to do 4 out of 8, because aren't they going to be smaller slices? Sure. But if you're talking about which way are you going to get more pizza or less pizza, you're going to get the same amount of pizza total either way. Yes?
It's kind of related to it, but isn't there a study though that shows that when our mind sees that there's more like pieces
Parts?
or something, it means like we're eating more again?
Oh yeah.
So like if you cut your sandwich in half.
Yeah, so that's a dieting trick, is to cut things into smaller portions and smaller parts, and then your brain gets tricked into thinking, I just ate more. Yes. Yes. All right, guys. Anything else from homework stuff? Anything we haven't done yet? Left over? All right, one last thing. We basically reviewed almost everything I wanted to talk about. Let's talk about mixed numbers and stuff again real quick, just to review it. And I'm going to give you this little sheet to work on. Let's do this first. 4. All right, Jeff. Let's try to just write the number 4. There you go, buddy. 4 and 7/8. How would I make that into an improper fraction?
You just do 4 times 8 and then plus 7 and then
11. Right, how's everybody with that? And I showed you the other day why that shortcut works. It's good to know shortcuts, that's great. It's so much better to know why they work. So I showed you why this works. So now it's 8 times 4 is
32,
plus 7.
39.
Now don't just stop there. I get people that just stop there.
No.
That doesn't make any damn sense. 4 and 7/8 can't be 39. That's neat.
39 over 8.
Good. 39 over 8. Beautiful.
And then
I like it. And how do I go the other way? Somebody help me out. What would 81 over 7? How would I make that into a mixed number?
81
Divide
over 7.
7.
Yeah, you can divide 7 into 81.
1, 7, 1, 11, 1, 7, 4, 11, 4, and 7.
Good. 11 and 4 sevens. And how do you check yourself? It's so much easier to do this, so it's a quick check. 7 times 11 is 77 plus 4. 81 over 7. The bam, bam, bam. Yes, ma'am.
I have a question. Say it was 4, if you're dividing that, say it was 4 sevenths over 8 divided by 5.
Whoa, wait a minute.
So
So
4
it was-
sevenths over 8.
4 sevenths over 8? Like that?
No. So 4 and then 7 8.
4 and 7/8.
Yes.
Okay.
Divided by.
Oh, look at you reading my mind. I love it. Good.
5 and 1 half.
Ooh, that's yummy.
So would you have to, before you do the flip or change, would you have to do 8? Would you have to turn it
Yes.
into actual
So guys,
fraction
when
before
we
you-
divide fractions, we multiply by the flip of the second fraction, right? That flip idea doesn't make any damn sense when it has a whole number part to it, because it's not just a top and a bottom I could turn. It's a whole number in the top and the, so I need to consolidate that, make it look like a single fraction divided by a single fraction, and then I know what to do. So this would be, of course,
24,
39 over 8 divided by
11.
11 over 2, which are going to make 39 over 8
And then
Divide
split it.
2,
Split
11.
times 2 over 11. 11, right? Is that cool?
Yeah.
And then, of course, what am I looking at?
4.
And that's it, right? Nothing else cancels? Become a 9, Joe. What the hell number is that? 39 times 1 is 39. That's crazy. 4 times 11.
44.
And the cool thing is, if you know there's nothing else that will reduce here, there's no way in hell anything can reduce in your answer, because it's made of these numbers. So as long as you completely reduce here, you don't have to waste any time here. You know that it's not going to go any further. Why does it make sense that this is less than 1? You guys agree with me that's less than 1?
No, yes, less than 1.
Yeah, because the top would have to be 44 to be 1. It's less than 1 because this is like basically 4 divided by 5, which would be less than 1, right? So it makes sense the answer is less than 1. Do you have to know what I just said? Not really, but it's nice to be able to estimate that the answer makes sense. Okay, yes? Sure. Let's see. Aw. What page is that? Of course, let me see. There you are. Ooh. Ew. I like this problem. Let me see. Normally that means horrible things for my students. This is 390.
Oh yeah, I just did it.
Yeah, you would just skip this. But if the thing I gave you was that, and you skip it, I would really be very sad. I mean, what does 1/5? What does anything squared mean? You take that thing and you multiply by itself. So the top is easy. The bottom, if I gave you that as a problem, everybody in here should be able to just eat that one up, right? That is a very in-your-face order operations problem, right? So whenever I have a fraction where there's a lot going on the top, and there's a lot going on the bottom, don't just give up on it. The top is a problem, do it. The bottom is a problem, do it. And then at the end, you look at the top and bottom and see if it'll reduce, right? Or what else, whatever you can do with it. So on the top, what is 1/5 times 1/5?
1 over 25.
Yeah, 1 over 25. That's on the top.
Yes.
What can I do first on the bottom? What must I do?
2 plus 9.
2 plus
Yeah, 3 squared, because exponents before addition. 2 plus 9,
Plus 9. 11.
11.
100.
Now, again, whenever you have a fraction inside of a fraction, rewrite the division bar as a division. So this will be 1/25 divided by 11, which is 1/25 times,
1 over 1.
1 over.
Or 1 over.
it already was 11, yeah.
Yeah, 1 over.
And now you just multiply across. I mean, 25 times 11 is a little big, but you're done then. But see, that's the kind of problem you give up on immediately when it's really, it looks horrible because there's really 2 problems in one. But if you just do this for yourself, that's not that bad. That's not that bad. Get both of those done and then look at where you are. I mean, don't give up on it right away just because there's a lot going on. You know, just do one side and the other side. Yeah.
It's 25.
Oh, real quick, anything else about this?
Complete this.
You complete it. I'm tired.
275.
There you go. Yes.
Wait, what's 25 times 11? 375?
So watch. What's 10 25s? Now, I wish you guys would really get this idea. 10 25s is 250. That's
250.
so this is one more 25. 250 plus 25 is 275. So multiply by 11 is easy. You actually just multiply by 10, and then you add one more of it on top. Yeah. See, that's the kind of thing that I wish would be allowed for you guys to pick up as you go along. It'd be great to already have known that kind of thing, before today. Okay. I'm sorry. Who did it? Did I skip over somebody? No. Okay. All right. So let's do this. Let me first figure out which ones I want you to do. That would have probably been a good thing to do ahead of time, John. Oh well. You'll deal with it. Let's see. I want you to do 672 through 678. And then let's see. Yeah. 680 through, let's say, through 695, every third one. All right. Just to kind of slice through this. This is the practice test out of your packet from chapter 4, by the way. So I've got copies, but if you have your little packet, I of course chopped off the page number for this. So,
I did the wrong numbers for a whole chapter.
shit.
2 questions in, I one.
Here we go. This page 404 in your packet, right? Page 404 in your packet. I want you to do those problems. Let me know if you need a copy of it.
What packet are you talking about?
This whole row here. The chapter 4 packet.
Oh, the homework.
Yes,
Oh.
the chapter 4 from the book. Yeah. Who else needs a? It's coming.
Along with this one. Yeah, it's right off the bat, right at the very beginning. I didn't know that the variables so variables when you times them, you actually just times them. I forgot.
Yeah, like x times y would just be.
I just separated them like.
So Alan, are you working with him? Yeah.
All right, guys. So you guys, just to make sure, 672 through 678, and then just to make this last part easy, it's 680 and then just straight down to 695. Bam. That'll be every third one. Do you guys see that? Just do bam. No, we're going to talk about it today. It's a little review. It's a review of all the stuff we've talked about so far, basically. Do it right now. Yeah. That'll make your work better. You can work together if you want to. It's not a quiz.
Yeah. Thank you.